5, Chapter 10, Learning Objective 21. Learning Objective 21 states to draw Lewis dot structures for atoms. So when I want you to draw a Lewis dot structure, you are only going to draw the Lewis dot structures for the main block elements. Now, what is the main block? The main block is the S and P orbitals, or S and P blocks of the periodic table. So anything that has NS2, NP6, or NS2, NP blah, 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 that would be the main blocks. So the Lewis dot structures, all they are concerned with, because we are starting bonding, are the valence electrons. The valence electrons are what bond in an atom. So this shows the valence electrons an atom has as dots around the element symbol. So what a Lewis dot structure shows is where the atoms can bond. These would be the single dots. And it also shows unbonded electrons called lone pairs, which are 2 dots. Okay, so then let's look at this. So in group 1, so I'm going to do groups 1, 2, 13 through 18. So from a previous chapter, we learned that the valence electrons correspond to the ones place on the group number. So for group 1 elements have 1 valence electron. Group 2 have 2. Group 13 have 3. Group 14 have 4. Group 15 have 5. Group 16 have 6. Group 17 have 7. And group 18 have 8. This is with the exception of helium, which has 2, which it only has 2 electrons, so we can't say that they have 8. So we have that, and then we have the Lewis structures. So the Lewis dot structure would have the symbol of the element. So lithium, Li, and it would have one lone little dot right there. That's it. Okay, and then for group 2, it would have the symbol. So calcium, Ca. And it's going to have 1, 2 dots. Okay. So when we draw these, we're going to pretend like the symbol has like little, it's like a box. We don't put any dots on the corners. We just put them on the lines. Okay. So group 13 has 3 valence electrons. So we would have the symbol of the element, and it would have 1, 2, 3 dots around it. So group 14, symbol, and then 4 dots around it. Now notice you're putting a single dot in each of the one line on the symbol. That is also Hund's rule. Remember Hund's rule from the electron configurations. You have 1 electron going in and then you double up. Same thing goes here. Okay, group 15, you're going to have your symbol, 1, 2, 3, 4, and 5. And then group 16 symbol, 1, 2, 3, 4, 5, 6. It doesn't matter how this looks. You could have the doubles on this side, wherever you start. It doesn't really matter. You're just going around and putting 4 dots on each corner, and then you're doubling up. So you go around as many times as you need, 2 times is max. 1, 2, 3, 4, 5, 6, 7. And then for group 18, 1, 2, 3, 4, 5, 6, 7, 8. And those are the Lewis structures for the group 1 elements, group 2 elements, group 13 elements. It doesn't matter. So again, it doesn't matter. It does not matter. It does not matter what element is here. It always has 1 electron here. Whatever element is here always has 2. Element here always has 3 if it's in group 13. Again, we're not going to do d orbitals or f orbitals, just s and p.